Well, hi, and thanks for joining me in my shop here this morning. I'm going to be talking a lot about tubes and tube testing. You can see on my bench the 5 tubes which have come out of this radio, which I'm working on right now. And I've run these tubes through my tube tester, but not just one. I've run them through 3 tube testers. You can see one of them sitting here. So I'm going to talk a little bit about the tube testers that I've used, and then we're going to spend most of the time looking at the results from testing these 5 tubes in these 3 tube testers. So here's one. This is a great tube tester. This is a Stark 966, very common tube tester in Canada or Ontario where I live. I think this was made in Ajax, Ontario. So this is my go-to machine. I've had this for decades and I've used it, and never have I ever had the sense that this was not giving me good guidance. So that's a great tester. That's one of the ones I used. So all these tube testers are dynamic tube testers. They test the tube for its mutual or transconductance using dynamic signals, which means it's applying something other than straight DC. Let's leave it at that. So here's another great tube tester. I've had this one also for quite a while, but I've only recently brought it into service. I thought it was a dog, and I discovered when I got it in here and started working on it that this is not a dog of a tube tester. This is another great tester. This one not only measures GM, it will also measure the emissions. So this is also an emissions tester, but it's no toy, that's for sure. That's quite the machine. Precise tester. Now I have one more. That's this one. So now all 3 of these testers are bench testers, serviceman testers. These are the kind that your TV repairman would have, especially that 966 Stark one. So this is another fine mutual conductance. This is a mutual conductance tube checker. My experience with this one has been great also. My experience with the Precise is limited yet, so I can't say too much about it. But never has this led me astray in any way either. So this is another great tester. They all measure GM, and that's where we're going to spend a lot of our time talking. I do have other tube testers. I might as well flash this out since I'm showing off tube testers here. I might as well flash this guy. So I did not use this one, kind of for obvious reasons. This is a really old tube tester. This is from the early 1930s, and it doesn't know anything about an awful lot of the tubes that were developed after this tube tester was made. There is a supplementary chart for it, but this is an emissions tester. It's a really simple machine. So I would only employ that for fun when I'm working on really old radios from the 20s. Just for fun, I would pull that out. So, and I have an emissions tester which I did not use. My experiments with my emissions tester when compared to this guy and the other 2 dynamic testers is, don't waste your time with an emissions tester if you have one of these guys. That's for sure. So we're going to flip over now. We're going to look at the results. I'm going to have to talk a fair bit to explain exactly what is on my chart. And then for the first time, you and I are actually going to really study these things. I was in here late last night taking the tests, but I really did not study the results. So that's yet to be done. Let's take a look at them. Okay, so before we get looking at these 2 tables carefully, let me just say that all the tubes tested okay in this radio. So let's take a look at this top chart first. The bottom chart is a simplified version of the top chart. Let's understand the top chart really well. There's quite a bit of eye-opening information in here. So there's 3 tube testers involved: the Stark 966, the Weston 981, and the Precise Model 3. All these I believe to be in good working order. I have no reason to think they aren't working the way they are supposed to work. The tubes involved are these 5 tubes, which have come out of I got 6 tubes here. 5 tubes. This one's got 2 lines here, the 6SQ7. They've come out of the radio I'm currently working on, which is the RCA Victor A23. This is probably how I'm going to test tubes from now on, I'm saying. Takes a long time to develop this chart, but I think this is really the only way to get a grip on everything all at once, and that includes my understanding of all this stuff too. So here's the tubes. You'll see some of them have some words after them. So the 6SA7 is a double triode. There's a triode 1 and 2 in it, and so you can see I've split the readings, but look, there's no splitting of the reading here because this tube tester tests the whole tube. See, this is part of the problem in comparing tube testers. They're not doing exactly the same thing, and they're not doing it in exactly the same way. You'll see more of that as we go. So 6SK7 simple tube, 6SQ7 has a triode and a couple diodes in it, so it's not simple. And the 5Y4 is a rectifier tube. You'll see on the diodes and the rectifier tube, I've just written weak and good. There is no mutual conductance reading in a tube without a grid. You need a grid in a tube to create this concern, if you like, around mutual conductance, or there is no mutual conductance in a rectifier or a diode. So you end up just with these words, weak and okay. So, and then the output tube here, the 6K6 is also it's a single purpose tube, and there's the readings for it. So now, in understanding these readings is not easy. Each tube tester declares a rejection point value. Let's start with the start. What I've done is I put the rejection point values in brackets. The first number is the rejection point. So in other words, if you test a tube and you get a 470 or less on this kind of tube, then you should throw it out. You should get rid of it. The 750, I believe, is a typical value for this tube, normally operating without much wear and tear on it. I believe that's what the higher number is. You might even think of this as the out-of-the-box number, but there's issues around tubes out of the box, which I won't get into right now. So this is really the number we're interested in. How low can you go before you got to throw it out? So if you compare it to the two readings here, you compare the 550 and the 800 to the 470, you can see that this tube, not so good on this particular triode, much better on this one. In fact, this number is above that number. So that's how this is working. So value taken and rejection point. So we took a 1800 measurement of GM, and the rejection point is 1200. So this is testing very good. So that's what these numbers are in the bracket. Now here, let's compare. Let's go from this over to this. Oh, it's not a good comparison because this tester has chosen to test both halves of the 6SA7 simultaneously. So it has a very different number here, 1100. If you notice, 1100 is not really double 470. Not really. Let's go on to the next one. If we come over here to the precise tester, now it's doing two tests, and it even tells me which section is the amplifier section of the tube, the two-part tube, and which is the oscillator section. So I wrote those words in here, amp and oscillator. So the amplifier side is supposed to be at least 775 on a GM measurement, and it's coming out at 750. So this one's actually failing. But the other half of the tube is fantastic, the 4000 out of 2800. Let's just think about that for a minute. This tester is telling me half of this tube is too weak to use. This tester is telling me the whole thing is great. And this tester is telling me one part of the tube is pretty close to the line, but it's still usable. That's three different messages from these tube testers, as much as I was declaring how fantastic they are. So this whole tube thing is hiding this. It's hiding this. You can see it here. Let's look at the next tube. The next tube is simpler. It's just a single amplifier, 6SK7. So on the start, it's supposed to be 1800. Could be 1900 would be normal. I guess that's what that means. But you can run this tube down to 1200. So this is coming out pretty good. This one, 2000 out of 1500, it's coming out pretty good. This one's 3400 out of 25, it's coming out pretty good. But look at the difference in these numbers. So if you think what's written on these roll charts is the GM of the tube, you are mistaken. There is no GM of the tube. there is a GM which can be measured, a mutual conductance which can be measured under known operating conditions. Change the operating conditions, change the GM reading. So you can't compare these numbers directly. Look, 3450, 2000, 1800. The numbers don't compare at all. And if you look at the ratings, 1200, 1500, 2500, wildly different. So within the world of each tester, this is all making sense, I think. We're going to find out in a moment. Let's just keep going. We'll just take a peek at this one. 6SQ7. So coming out almost double this. This guy, quite a bit higher than the minimum. This guy, below the minimum. So this tube, good here. Good here. Failed here. So, wow, okay. I'm looking at these for the first time in detail with you, so if you hear a surprise in my voice, I am surprised. I'd only glanced at these before. So let's look at the 6K6 now. So 1800 out of 1010, that sounds good. It's higher than the 1600. This sounds like a great tube. Here, great tube. This guy, 17 out of 13, that's great. This guy, 750 out of, say, not so good. I don't know what's going on with this. Now this is the tube tester I have the least experience with, and I was in the process of restoring it and then calibrating it. I'm not sure I really completed the calibration process on this guy. Now to make these things more comparable, what I've done is I've made another table down here, and I've written in here percentages. Let me just put the percentage symbol in there. These are the percentage the reading is of the minimum. So if we take the Weston test of this tube, the 6SA7, tested at 150% of the minimum. The minimums are different on each tester, but this percentage I think is comparable. So we could say in this tube in the Weston tested 150 of minimum. Here it tested around 100 of minimum, and here it tested 100 and 150. So what I do with this tube? Next one, Stark test this tube really good. 150% of minimum, 130%, 130%. So these are consistent. That's unfortunate, because if the precise tester was consistently inconsistent, I'd feel better. But it's inconsistently inconsistent. Let's look at the next one. So here we've got 150. Funny, these are exactly the same. How did I end up with exactly the same? And I do some calculation error. This one I noticed, and I checked up on the chart, and it is exactly the same. This is 2,000 out of a possible 1520, or a minimum 1520. And this is 1,000 out of 760. I remember doing these tests, and as I took these readings, I was a little stunned to see the pointer come up and land right on a round number like this. But it did, and it did it again here. So kind of surprising, but that's just a coincidence. Let's check this one. So this is a 6SK. Maybe I just made a little mistake. No, 150 and 148, I just rounded it up. So that opens up the door to another analysis here, but let's keep going across, and we see good, and bad. Here we see good, and really ready to go out the door. So the precise tester is testing low. That's what I would say, except here. So there you go. This is what happens when you have too many tube testers and too many tubes. Now, if you look down at the bottom of my spreadsheet, you'll see lots of tabs here. These are other tubes I've been testing in the background here. When I'm getting too bored in the evening, I come in my shop and throw away a couple hours testing tubes. So let's just take a peek at this 6SK7, because there's one here. Let's get the actual number. Stark 1800 on a 6SK7. So this is done with the Weston. I didn't do it with a Stark. There's a whole bunch of 12 SK7s, but that's okay. 12 or 6, same sort of deal. I've got some 6 here too. So let's go back to the check the Weston here. So the Weston read the 6SK as 2000. Okay, keep 2000 in mind, that should be pretty easy. Oop. SK. 2000. So here we're using the same tube tester now on a whole bunch of tubes. So we just look down here. Is 2000 a weird number? No. Lots of these tubes tested. Look at this one, 3100. Now there's a tube you want to have. All in every one of these is in the 2000s except for this guy. Look at this 6SK7. It's the same tube with a different heater voltage. And very, very similar readings except for this. This has nothing to do with this. These are two different tubes. 12SK7, 6SK7, tube number 6. Down, but otherwise, we're all up in the 2000s. In fact, they're way over 2000, aren't they? Really, they're all, except for this. Now, some other observations I'm making when I'm doing these tube tests is occasionally when you push the test button, watch the cursor here, the pointer will go up and stick, like that. Sometimes it goes up and falls back quickly. That's just momentum in the pointer. But sometimes it does this. It goes up, back, and then it just starts drifting down. And that drift can go on for quite a while. A minute, 2 minutes, 3 minutes, that kind of thing. So I've been noticing the slip, the drift, and I put it in as either a fall. Fall means it went up and then fell down. Slow finish means it went up and then slowly drifted upwards, like it had a hard time finishing, and that's what the slow finish is. So clean? I don't remember what? I don't remember what I meant by clean. Oh, the tube. Now, you know what this means? The tube looks brand new. That's what that is. So you have a brand new looking tube, and what is it testing at? Good. Okay, there's lots more tube testing analysis to do. I'm just going to throw you at a couple others that I've been doing. Here's the Stark and the ICO. The ICO is an EM tester, comparing those on a 12SA7. Hey, wait a minute. 12SA7, let's take a look. So again, a 12SA7, 6SA7, same tube. So the kind of numbers we're getting here, I see all the fall off, fall off, fall off. So let's look at the ones that aren't falling off. We're getting numbers like 600 and 900, 600, 850. The two halves of the tube test quite differently. 750, 850. Even though, oh yeah, see, one half of the tube, the rejection point is 470, the other half is 750. So it's probably 470 and 750. So you can see a pass and a fail. No, you know what this means? No, how can you know what it means? I'm the one who did it, for crying out loud. This means I did the test twice. I came back onto this tube and this tube tester and repeated the test, and I made notes. So you can see some of the consistency in the testing too, from time to time. And I test the same tube more than once. You can see it over here a little bit. Not very good there. Oy. Yeah, believe me, I'm not impressed with EM testers. Not at all. There's nothing impressive about it. So typical numbers here, 700, 400, 600, 600, 450, 450, 700. So kind of between 450 and 800, let's say, something like that. 450 and 800 now to the 6SA7. It was on the Stark 450 and 800. Well, I don't know, nothing leaping out at me. Anyway, as you can see, there's an awful lot of data to swim around in here, and that's about all I think I want to say. So bottom line on these tubes for this radio is I think they're okay. Looks like we might want to fiddle around with them down the road once we have a radio all tuned up, and we might want to try putting in a better, quote, better 6SA7, see what happens. But I don't think there's any reason why this radio wouldn't work. I'll take that back. I'm going to take that back right away. The diode side of the 6SQ7 tests weak on all these testers. Now this is kind of a good-bad sort of test. It's not so much a measurement. this one where I have the question mark on the precise, the pointer came right up between good and bad where there's a question mark. So this tube I should probably change out. What it might indicate is that in this radio only one diode is utilized. The other diode may be not utilized in this radio. So it's sitting in the tube but nothing's happening with it. I'm not sure. Yeah, I should think about a 6SQ7. I have a few. I have a few. Ooh. So here's my 6SQ7 testing where I've done a more thorough job and gone through with all the testers on here. But we're not going to study this yet because this really has to be analyzed very carefully. And what am I looking for? I'm looking for a 6SQ7 typical, you know. So what I can do now is I can look down this chart. I can pick a particular tube that I'd like to get and stick in a radio or do something with. Tube number 8. This is sitting in an egg carton right now with a number 8 on it. So I can find this particular tube. And I'm trying to set myself up to be able to experiment thoroughly with all these testers and all these tubes. In the background, I'm testing my tube stock. I'm trying to make sure I know what I'm doing while I test it. And I'm also trying to improve my knowledge on tube operation. And yeah, that's a lot. There's a lot to know. Okay, I've talked a mile on this. Let's go back to the radio. So again, bottom line, tube's okay. 6SQ7 questionable. And that's it. So I've cleaned up the radio now. The dust has been removed. I'm going to pop the tubes back in. I'm going to make the permanent cord replacement before we go any further with it. And then we're going to start doing some component replacement. Probably test it out again once I put those tubes back in, just to make sure everything is working as well or not well as it was. And just over here, just to remind you, this is my own tube testing jig here. As I mentioned, I'm trying to become a little more expert on tubes and tube testing, and I'm not so sure this is going to do it anymore. But we will see. As it turns out, you know what we're going to do right now, because I think I have time on this video. We're going to get the precise tube tester out, and we're going to try to make a curve on my scope using that tube tester. A characteristic curve. So apparently it can be done. Let's give it a try. So no, we're not going to go ahead with that because I started to read the manual for this tube tester, and there's a whole pile of stuff I can do with this tube tester that I've overlooked. So I'm going to read up on the advanced capabilities of this tube tester, and I'll make a separate video. I'll try to better utilize this particular tube tester. So great. So thanks for watching, and we will get back to the radio and get it playing next video. But rest of today is going to be tube tester day for me.